Any other?
Okay. Yes, sir. Please, can I come in?
Yeah, sure. That.
Please, we also learned how to use the longitude to calculate time and then the latitude to calculate distance. And we also learned that the distance of please just a minute, the distance of 0 to 23.5 is 111 kilometers. The distance of 1 is equal to 111 kilometers.
Are you done?
Yes, sir.
All right, thank you. So we said every 1 degree latitude is equal to 111 kilometers. And that's even some books will tell you is 111.1. But if you state 111 kilometers, it's accepted. That's fine. All right. So we will want to continue, and we are looking at structure and composition of the earth. Structure and composition of the earth. So what it means is that we must first have the structure before having the composition. So in terms of the structure, how many do we have? In terms of the structure, how many do we have? What do you think? The structure of the earth.
So I think we have 4.
All right, thank you. In terms of the structure, they are categorized into 2. This is the internal structure and the external structure. The internal structure, then external structure. So the external structure will be the atmosphere. The internal structure will be what we will have on the ground, which we'll look at first. Now, we always say that the earth is spherical. And with its sphericality, we say it is not a total sphere. That's why geographers call it geode. So geode, the meaning of geode is the earth shape. Meaning we don't have anything. We do not have anything that has a shape like that of the earth. So the earth is very unique, and we are giving it a name, and it is called the earth shape. Now, what you should understand is that we have some parts of the earth being gaseous, other parts being liquid, other parts being solid. So internally, we will have the lithosphere, the asthenosphere, the mesophoric mantle, the outer core, and the inner core. So internally, we have the lithosphere, which is also known as the crust. We have the mantle, which is also known as the mesophoric mantle. Then we have the core, which is divided into 2. But the asthenosphere is the fluid aspect of the earth, which we say it is the asthenosphere. For this lecture, we'll look purposely into the chemical composition of the earth. And with the chemical composition of the earth, we say we have the crust, the mantle, and the core. So we mostly see the internal structure of the earth is divided into three: the core, the mantle, and the crust. The core, the mantle, and the crust. The core, the mantle, and the crust. So looking at what we have, what does the crust mean? So the crust is made up of two main layers or parts, which we say that we have the seal, we have the seal, and the seal is made up of silica and aluminum. Silica and aluminum, which is the seal. So the seal is silica and aluminum. And the seal is having an average density of 2.7. So the crust is divided into two main parts. The first one is the seal. Now, we also have a continuous layer, which is beneath what we have just talked about, which is the seal, called stigma. So the second layer is called stigma. And the meaning of stigma is silica and magnesium. So seal, silica, aluminum, then stigma, silica, and magnesia. The stigma is having an average density of 3.0, which is a bit different from what the seal is having, which is 2.7. Now, when you put the seal and the stigma together, it gives you the solid rocks. It gives you the solid rocks. So the solid rocks of the crust is termed as seal and stigma. One thing we should understand is that seal is a bit lighter and it floats on the stigma. So they can ask you, which of the composition of the crust is lighter? So the seal is lighter than the stigma. So the stigma is rather heavier. The stigma is always heavier than the seal. So because it is heavier, it tends to sink. So it is always at the base on which the seal floats or suspends. Because
Sir, please, your line is breaking.
oh, sorry. So where do I take it from?
The steel and the steamer. Said
Okay,
one was
thank you.
heavier. That's why you left
Okay,
two.
thank you. So we are saying the seal is lighter, while the simmer is heavier. And as we are all aware, whatever is lighter will never sink. Whatever is lighter will never sink. It will rather float. or suspend. So the seer floats on the steamer because it is a bit lighter than the simmer. So the two, we say the simmer is heavier and that one sinks. And as it sinks, the seer float over it. So if you have the simmer and the seer is always sitting on the steamer. That is silica and aluminum are sitting on the silica and the magnesium. So what carries the Cl is the simmer. That is what we have for the crust. But in terms of its thickness, we say it is a range between 5 to 6 kilometers beneath the ocean. But on the continent, it is about 48 kilometers under. That is the crust, which you call the lithosphere. Don't get confused, because when we were talking about the divisions or the spheres of the earth, we talked about the lithosphere as one of the spheres. Yes, here too, it is one of the components of the internal structure that we have. And if you don't see lithosphere, you will see what is called crust, and they are basically the same. Some people will ask you to give some importance or benefits or relevance of the lithosphere or the crust. And when you get it that way, you should just bear in mind we are talking about the solid parts of the earth. So what benefit do you get from the solid parts of the earth? That would be the only thing that you have to think of. Now, let's go to the next one you call the mantle, which other people call it the mesophoric mantle. Now, the mantle, where is it found? The mantle lies in between the crust and the core. The mantle lies in between the crust and the core. Now, it separates, so far as it lies in between the core and the crust, it means it serves as a separator. It's just like you've put margarine in your bread. One is at the top, one is at the down. Or one is at the left side, one is at the right side. So whatever hang in between, or when someone says in between two people, you should have the betweener. And the betweener is the mantle. So with this mantle, we have other name, just as we had for the lithosphere, which is called the mesosphere. So mantle is also known as mesosphere. And we say that the main mineral found there is called the olivine, but not Oliver and not Olivia. So the main mineral found there is known as the olivine, and it has an average temperature of over 1900 degrees Celsius. The temperature that we have within the mantle is above 1900 degrees Celsius. 1900. But its thickness is around 2009 kilometers. So the thickness is around 2009, but the density is 3 grams. Now, the mantle also has two divisions. The mantle also has two divisions. We have, in this instance, the upper mantle and the lower mantle. The mantle is divided into two. We have the upper mantle and the lower mantle. Now, what we should understand is that the upper mantle is solid. The upper mantle is solid, whilst the lower mantle is liquid. But this liquid is not water. It is what you call fluid. It is a fluid. Because a fluid can be kerosene, the thickness. It can be water. Fluid can also be gas oil. Fluid can also be something like mpampa. Fluid can be normal porridge. Fluid can be rice porridge. They are all fluid. But if you say it is liquid, then it is just something that flows. But fluid flows, but some instances it does not flow that fast. Now, these words are what you should take note of them. The line that separates the mantle from the core. I said the mantle lies in between the core and the crust. So the border between the mantle and the core is termed as Gutenberg discontinuity. Gutenberg discontinuity. So we have a border or a line that is in between the mantle and the core. And scholars have given it a nice name. And that name is known as Gutenberg discontinuity. Gutenberg discontinuity. Gutenberg discontinuity. So we have the structure of the earth, the structure of the earth. Now, the line that separates the mantle from the crust is called Mohorovičić discontinuity. Mohorovičić discontinuity. Mohorovičić discontinuity. That is the line that separates the crust from the mantle, or the line that separates the mantle from the crust. Mohorovičić discontinuity. And the line separating the mantle from the core is known as the Gutenberg discontinuity. So these are few things that we have under the mantle. Now let's look at the last one. The last one is termed as the core. Now, the core is also known as barysphere. The core is also known as barysphere. So anytime you hear about barysphere, when you're talking about the internal structure of the earth, you should be thinking about the core. The core is divided into two, or it has two parts. We have the inner core and the outer core. So even though you say we have something called the core happens to be the nucleus or the innermost part. Even within the innermost part, it's still divided into two, the inner core and the outer core. Now, we have two main minerals, very, very important minerals found in the core. And those minerals are nickel and iron. Nickel and iron. We call it knife. Why is it called knife? Why is it called knife? Nickel, its SI unit is Ni. Then iron SI unit is Fe. So knife is the same as nickel and iron. So if you cannot remember to write nickel and iron, you can write knife, which is accepted. Now, with this core, one of its parts is solid, while the other is semi-liquid. One of the parts is solid and the other is semi-liquid. Which of the parts is liquid and which of the part is solid and which other part is semi-liquid? Yes, Millicent.
Sir, please, the inner core is solid and then the outer core is semi-liquid.
Semi-liquid, thank you. Any other counter opinion? Yeah, Ima. Yeah, you.
So the outer core, the inner core is in a solid state, and then the outer core is in a liquid state.
All right, thank you. So we're saying that the inner core is solid, is hard, but its peripheries or the outer parts is said to be semi-liquid or molten. Then they are given a very high degree Celsius temperature for the core, which is over 2000 degrees
Sir, please,
Celsius
your
as a
line is
temperature.
breaking.
What's happening?
Sir, we can't hear anything. Sir, please, your line is breaking.
Thank you.
Maybe it is your network. Some of us can hear him clearly.
Okay, so please, as many that can hear me clearly, can I see your hands? Okay, that's fine. Thank you very much. You can put your hands down. Yeah, madam, I think like he indicated, I'll try to position myself very, very well, but to also do the needful, and we have a peaceful lecture today, all right? But if you're not able to hear anything, don't hesitate. Just draw my attention. I'll repeat whatever I said or we have talked about for you to have all that you need to get today. Thank you. Alale Ralph, your hand is up. Okay, that's fine. Now we can continue. So we're still talking about the core. It has its thickness, it has its density, it has its division, it has its temperature, and it's happening to be the innermost part of the internal structure of the earth. What have we heard so far on the internal structure of the earth? What have we heard so far? Atanga, please let me hear you. Steve, please talk.
So I've heard as the mantle lies between the crust and the core, and its thickness is over 2,900 kilometers, and its degree is over 1,900. And also the mineral that is found there is called olivine. Thank you.
Thank you. Abredu.
Yes, can I come
Sir.
in? You called me earlier, but
Okay, let me
yes,
finish
so
with
I have
Abredu, then I come to you at Atanga, please.
okay.
So I've also learned that the crust is also known as the lithosphere, and it has been divided into two main parts. So the first part is the seal, and the seal contains silica and aluminium, having an average density of 2.7.
All
And
right,
the
thank you. Lucas, please let me hear you.
Yes, so I have also learned that the core is also called the barysphere, and it is divided into the inner core and the outer core. Thank you.
Imanoamua, please let me hear you.
Okay, sir. So I also heard that the crust is made up of two parts, the seal and then the sima. The seal is the silica and aluminum, and then the sima is the silica and magnesium. The seal is 2.7.
Yao Manson, please let me hear you.
Okay, and the core has a mineral which is called, there are two, nickel and iron. And in order to
Prince
shorten it,
Aganu, please let me hear you.
Sir, please,
hello.
I've
Okay.
learned that the line that separates the core from the mantle is called Morovisic discontinuity. And then the line that separates
Helly K, please let me hear you.
Sir, I have learned that the line separating the core from the mantle is Gothenburg discontinuity, and the line separating the mantle from the crust is the Romovic discontinuity.
Papa Dixon, please let me hear you.
So I've learned that the core is also called barysphere.
AJ Steven, please let me hear you. Brad, please let's hear you. Okay, Ejaman, so please, your hand is up. Hamidu, please, let's hear you. Ejamua, please, let's hear you.
So with the crust, the CL is less denser than the seamer. So the CL floats on the seamer.
Yes, mister. Thank you.
You're welcome, sir.
All right. Manfo, please, can we hear you?
Okay, so what I've learned today is that the Earth's structure is basically divided into mechanical and chemical. Chemically, it is divided into three. That is the crust, the mantle, and the core. And mechanically, we have.
Please, let's hear you.
Hello, sir. Sir, what I've learned is that the crust is also known as lithosphere, and it is the outer or the tiniest layer of the earth.
Thank you. Samuel Apabla, please, let's hear you. Mr. Joseph Afram, please, can we hear you? Okay, so they're all absent. Thank you. I'm taking note of them. All right, that's fine. Now, okay, Fia, thank you. I've read that. Thank you. Now, we have looked at the, oh, sorry. Is there any questions so far to discuss? All right, Elia Prince.
Sir, please, my question is about the core. Is that the inner is hard and then the outer is somewhere liquid, but it has a high temperature. So I don't understand why it has a high temperature and then the outer is molten and then the inner is solid.
All right, thank you. So you are realizing that it is sharing boundary with the mantle, and portions of the mantle is a bit of molten. So it takes those characteristics. At the same time, too, because of the frictions that they have there, when they are transitioning to a different one, if not, it will not be able to float on it. You know, just like you said, the earth is moving and the rest, some of them are floating. So they tend out to be a bit of molten, so that the others can just suspend on it and that way. And just as if you are coming from a father who is more or less like a white, you are more likely to be a white. Unlike that of Amma Dixon, who is coming from a father who is dark and she's fair. That's very unfortunate. All right. So Yusuf, Ismail, please, let's hear you.
Sir, please, can we say that the lithosphere is the most useful structure to man? Can we just say that?
You want to put some words in my mouth this afternoon. I want someone to answer. Yeah, Manfo, you are there. Dixon, you are there. I didn't cry, you are there. Steve, you are there. Please answer him for me. All those of you here, answer him. Oh, my good people, you are all here. David, Halid, Mundu, Akabla, Efia. Okay, they said the question again. Good, my people are there. They said the question again, big man.
I was asking that, in short, can we say the lithosphere is the most useful structure to man, in short?
Okay. Handsome, yeah, Manson.
Yes, please. It is because that's the part of the earth that human beings interact with most. So I believe that's the most important part of the earth to mankind. Thank you.
All right. Beauty, adorable
And I was,
Judith Daliku.
So I think it's one of the most important because that is where human settlement is, and that is where we happen to find ourselves.
All right. The conversation is becoming interesting. I will have my own view. Handsome, AJ Steve.
hello, sir. Yeah, I think they are all important because without them, they are interrelated. So without one, there's no way we can get one. So I think they are all important.
Handsome, Prince. Okay. So Paul Clement said no because other layers also have their own importance. That's fine. Ju, you want to speak again? Okay, Ju, go ahead.
So I think it shouldn't be that it's the lithosphere is the most important because all other
Network is very
are
terrible.
also very
Can you hear
important.
me?
Yeah, Judy, please go ahead. I can hear.
Okay, so I was saying that um thinking of it again, I don't think the lithosphere is the most important because
It's
all
also
other
come.
come to play. They all play a factor. So we can't say that the lithosphere is the most important.
So
Oh, okay.
it's like
Handsome,
they are like system.
Crispin, Osei, Kufo. Apa
Okay.
is your voice I want to hear.
So I think as humans, all these things we interrelate with them, and then we are interdependent to some of these elements. So to say one is the most important, to me, I think will be false because we interdepend with one another, and without one, um, it will be difficult for one to live. Thank you.
Thank you.
Sir, please,
Yeah.
I want to get something. Did you say that the person who asked the question, did he say that important to human or what? If it is important to
Yes, I
human, then it is true because that is a conducive place for human settlement. That is my take on that.
Who is speaking?
Abba just
Hello,
spoke.
sir.
Okay. All
So
right, that's fine.
looking at the question posed by our brother, the emphasis was on mankind. So looking at the layers, which of them uh, is beneficial to man most? So looking at the benefit that the lithosphere comes with, it is outweigh that of the other two components. Thank you.
Wow, I'm loving today's class. I'm not saying that that class are not interested, but today, let me ask a simple question. Oh, sorry, Lucas, you're speaking. Sorry. Is it
Yes,
Victor
I
speaking?
Yeah,
yes,
sir.
I wanted to also say that we cannot select the caste and say it is the most important because we our settlement is on that and we are mostly interacting with that. We cannot forget the fact that we have other essential resources like minerals, like fuel and underground water that is also found beyond the caste. So that's the point I was also going to make.
All
Sir,
right, thank you.
I think he channeled the question to human settlement, right? If then
I think
yes.
he's best to answer.
Where is he? My
Manford, I
brother.
think it
Yeah.
was he
No,
didn't
sir,
say
my,
to
my main
humans
concern was
settlement.
with regards to man. among the
Regards to
structure of the earth that we have, which one of them is the most important? Although, despite the fact that all the structures of the earth are so important, but which one of them? Can we conclude by saying that the lithosphere is the most important? We all know that 80 is a good mark, but 100 is so superior than 80. So we know that 100 is so important than 80. That's what I'm just asking.
to just oppose between this, then I think all of them are important. They're interrelated. So you cannot pick one and then depend on that one and say, oh, this one is more important than. But when you channel it through to human being, then the crust will play a major role. But since it's not channeled through the crust, all of them are important, my brother.
Okay, thank you very much.
If you finish fighting, you tell me. So what's your problem?
Let's continue.
All right, I'm loving the discussion, but one thing is, no matter what, we can say one is important than the other, but we have to be very careful. Just as we say this, in terms of, if I say this, water or just water and land, which one is the most important? Another big question.
So I'll go for land.
Okay, that is you. I can also say that the egg and the chicken, which one is the most important? Then I can go for minerals and the land, normal minerals and the land. Which one is the most important? So they are all important, though. For example, a building without foundation is nothing.
Yes.
The one we're talking about, the minerals and the refined deep within the earth crust. Yes, as you go deeper, you get to a place where there's mantle, there's core. If those ones do not support the whole of the mantle that you're sitting, what will happen? Won't it collapse and the rest? But they are all important. I wouldn't say this is more important or that is not important. They are all important. Thank you. Sekufu, I won't let you speak, please. Or it's a quick one. Okay, it's not even.
It's okay. I think you've explained that because the other components support humans. So so you can't say that one is the lithosphere is the most important aspect, even though it is important, but without the other support from the other, it will be difficult.
You don't say the hand is important than the legs, or the legs are important than the whatever. They all have their own function. You have just 15 seconds.
Okay, sir. So yes, indeed, all of them they have their own specific functions. But then the emphasis was on mankind. So I think looking at all the benefit that each of the component comes with, then crust is more, it outweighs that of the other components.
Thank you. I give 15 seconds. That is for you, your own consumption. All right. So now let's look at the atmosphere. You see, we're talking about the structure and the composition of the earth. And we have just jumped from there talking about the structure and the composition of the atmosphere. So we have now left the internal structure and we go into the external where it is more of gases or gaseous. Just Stephen, please go ahead. Course rep.
Sir, please, I want to know your question, please.
I don't have conclusion.
Based on
My conclusion is that they are all important. But if you personalize it, you can get to the one that is important than the other. For example, your mother and father, which one is more important to you? Yeah, you use your own personal thing. For someone say your mother and your father, who is more important? The person will even deviate and say my grandmother or my grandfather. You see, one thing is what you feel and interact with, you think is more important than the one you have not. Sometimes. If that is the case, then every man or woman will feel that their partner is important and better than the other one elsewhere. But that is not the case in Ghana. They always feel the other one elsewhere is important. We'll conclude it later on. Also, forgive me. Okay, also give me a second.
Okay, well, they are all important
Thank
because
you.
looking at the mantle and the core, without them, um, we cannot survive on the little, I think, the craft. Thank
All right. He has crowned it all. Now, the structure of the atmosphere that we're talking about, the atmosphere is tend to be the gaseous portions of the earth. So I ask you, in your room, do you have gas? Then there's an atmosphere. On your compound, do you have gas? Then it's an atmosphere. In your study room, do you have gas? Then it's an atmosphere. Why do you go that you don't have gas? Then that place ceases to be an atmosphere. So if in your room you can breathe, then that portion where the gases are tend to be the atmosphere. Because say the atmosphere surrounds the earth. The atmosphere, it surrounds the earth because they are gases and therefore they will surround. So the gases surrounding the earth is termed as the atmosphere. Some books will tell you that the envelope, the word is envelope, and I believe you know how to use the item called envelope. They cover without leaving any space behind. And it's full of gases. The atmosphere is full of gases. And the gases that they have in the atmosphere are many and many and many and many. So the gases that we have in the atmosphere are oxygen, nitrogen, argon, carbon dioxide, lithium, water vapor, and the rest. But the dominant ones, which you call the constant gases, the dominant constant gases are nitrogen, about 78%, oxygen, about 20 to 21%, then argon, about 1%. Carbon dioxide, which happen to be about 0.03, very, very dangerous and very, very vital. Because this carbon dioxide make the atmosphere warm for us. It traps the heat for us. It's able to make us preserve some food. It makes some food and beverages, for example, the fizzy drinks, very, very good and tasty. The oxygen has its own importance. The other one is what? The nitrogen to help some plants to do well. Very, very important. Apart from that, you also say that the oxygen, it supports burning, it's made you breathe well. They are all important. Water vapor is able to help rainfall formation. They are all important. Within this, or then we say that the atmosphere is divided into 4 main layers. 4 main layers. 4 main layers. 4 main layers. And the 4 main layers are 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. So what is the 1, 2, 3, and 4 that we are talking about? Yeah. Yvonne?
So we have the stratosphere.
Sorry, troposphere.
Please, the way you are pronouncing them, take your time before you go or you bite your tongue.
I said troposphere.
Thank you. Any other?
Then we have the stratosphere.
Okay.
The
We have the
mesosphere.
mesosphere.
Okay.
The thermosphere.
Thermosphere. Thank you. So the four main layers are the ones that you people, my good people, have been able to mention them. And we call troposphere, stratosphere, mesosphere, thermosphere. Never say thermosphere. It's not the thermosphere. The.
Thermometer.
All right.
Thermosphere.
Now, within, we are not saying these are the only layers that we have in the atmosphere, but the major ones are these four. Within this and the outer parts, we have the ionosphere, we have the exosphere, we have the ozonosphere, and the rest. They even enter into what we call space. Now, the most important one to you, as you stay here, because you don't travel anywhere, is what is called the troposphere. The troposphere. The troposphere happened to be the first layer from the ground. So what it means is that the atmosphere you have in your room, when I say the atmosphere you have in your room, I'm talking about the gases you have in your room. When you walk around, the gases surrounding you, the carbon dioxide that you breathe out and the rest in and around, they are all part of the troposphere because say it is the first layer from the Earth's surface upwards. First layer. The first layer, troposphere. It is where all weather activities occur. That's why we get a fight. So if you say all weather activities or most of the dominant weather activities occurring here, it is within the troposphere alone that we have rainfall. It is within this troposphere where you have rainfall. So anytime you go above the troposphere, there's no rainfall. So it is within this zone, just a small zone from 0 to about 15 or 12 kilometers upwards. Just about 10 to 12 kilometers upwards. Some places are even having 8 kilometers upwards, depending on where you find yourself on the Earth's surface. So about 8 kilometers, which is not too far. That's where all weather activities occur. I've seen this hand up. Okay, it's down now. So for us to have rainfall, we should be thinking about giving thanks to the troposphere. It gives us the rainfall. And here, all the gases are in their rightful proportion. It's a very big word, you understand. When you say rightful proportion, if nitrogen is 78%, in the troposphere, it is 78%, doesn't decrease. If oxygen is 21%, it is 21% in the troposphere. It doesn't reduce. Now, one thing you should understand is that in this troposphere, there's what is termed as environmental lapse rates. Environmental lapse rates. Environmental lapse rates. In other words, we call it normal lapse rates. If I mention it, you know. I don't want to say it. Say normal lapse rate, which you have heard it. That is, the higher you go, somebody will continue, the cooler it becomes. So the term, the higher you go, the cooler it becomes, is what we call environmental lapse rate or normal lapse rate. And that means anytime you go 1 kilometer into the atmosphere, temperature reduces by 1 kilometer. Anytime you go up into the skies 1 kilometer, temperature will reduce by 6.5 kilometers. So those of you who did geography in the basic SS, sometimes they will ask you some of these questions in objectives. They will say, if a mountain is having a height of, say, 4 kilometers, and the temperature at the bottom here is 20 degrees Celsius, what will be the temperature at the top? So 4 kilometers. Every 1 kilometer minus 6.5, minus 6.5, minus 6.5, minus 6.5. Whatever you get happens to be the temperature at the top. Now, what we should understand is that the clouds are formed in this troposphere. So there's no clouds in any other atmosphere apart from the troposphere. In this same troposphere, we say that its uppermost limit is tropopause. A professor will say tropopause. It is tropopause. So when you get to the tropopause, it tells you you are the boundary here. You are the boundary, the uppermost limits of the troposphere. It's termed as tropopause. That's the last limit. From there, temperature will become constant till it begins to change. And as soon as it begins to change, you enter into a new atmosphere called the stratosphere. Stratosphere. Now, let's look at the stratosphere. In the stratosphere, we say it is very stable. And it extends from about 12 kilometers from the ground to the highest limit, 50 kilometers upwards. Don't forget we said the uppermost portion of the troposphere is between 10 and 12. So where it has ended at 12, up to 50 is the stratosphere. The good thing is that in this stratosphere, there is the ozone layer. There is the ozone layer. And here, unlike that of the troposphere, temperature rather decrease with height. Temperature decrease with height. What it means is that here, the higher you go, the hotter it becomes. So this, we call it positive lapse rate. Positive lapse rate. The higher you go, the hotter it becomes. The higher you go, the hotter it becomes. The higher you go, the hotter it becomes. And ozone is found here. And we all know the importance of this ozone, which prevents or absorbs the UVR, the ultraviolet radiation from reaching the Earth's surface, UVR. Now, one thing is that this layer is very, 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 very stable. This layer is very, 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 very stable because we don't have any turbulence in that area. We don't have any updraft and downdraft here. No. When we say don't have updraft and downdraft, meaning we are talking about something like there's no clouds formation and others here. Therefore, there's no rainfall here. So there's no visibility problem. Visibility is very clear. Visibility is very clear. Because the place is very stable, aeroplanes like operating in this layer. Aeroplanes like operating in this layer. Because you will not say the place is cloudy, that you can see. But most of the airplanes that fly there are international planes, not local planes. Because local planes, few minutes, they will have to, come down. And when you fly in that zone too, you get economical fuel consumption. That is a stratosphere. And in this layer, it extends up to a border, and that border is termed as the stratopause. Stratopause. So the stratopause is the boundary separating the stratosphere from the next layer called mesosphere. The stratopause is the boundary separating the stratosphere from the next layer known as mesosphere. Now, the new layer from the stratopause is the mesosphere. Now, the mesosphere is a layer that rises above the stratopause, and it extends to a height of between 80 to 85 kilometers. Now, it takes some characteristics like that of the troposphere, where the higher you go, the cooler it becomes, and which we have said it is called normal lapse rate. The higher you go, the cooler it becomes. But one interesting thing is that here, temperature can go as low as negative 90 degrees Celsius. Very cold. Very, very, very cold. And we all say the freezing point is 0 degrees Celsius. What about if you go negative 90 degrees Celsius? What will happen to you? That is it. So here, it is the coolest or the coldest parts of the atmosphere. So it doesn't allow some meteorologists and some other people to study the area. And because of that, some meteoroids and the rest cannot form there. They don't, because of that coldness, they prevent those meteoroids by burning them. Now, it is sometimes a bit difficult to breathe in that area because pressure there are very, 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 very low. And all the gases, like I said, they are 100% at the bottom. When you get to the mesosphere, they tend to be left with only 1%. They tend to be left with only 1%. I wonder how that will be. If you were breathing oxygen, fine, you get there and you get just 1% of what you are consuming. You'll be a dead goat. You?
Sir, please, the slides are not showing. No.
So you can see, right?
Now I can see.
All right, that's fine. So we are saying that the pressure, which at first was very good at the bottom, sea level, has now gone down below 1%. Meaning the higher you go, the more the pressure continues to drop. From there, you go to the next layer, which is called the thermosphere. But the boundary separating the mesosphere and the next layer, which is the thermosphere, is called the mesopause. Mesopause. Mesopause is the next layer. Is a boundary separating them. Now, the thermosphere, which happens to be the last major layers of the atmosphere, the last major layer of the atmosphere is thermosphere. It extends to about 80 kilometers upwards into the atmosphere. So it moves up and up and up for about 80 kilometers. Now here, you have high rate of ultraviolet radiation, which are turning things, temperatures into very high heat. Because of the presence of this UVR, because don't forget, it has not been trapped because it has not got to the ozone. It is high up there, and it's making temperatures there abnormal, very, 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 very high. Now, what happens is that because the temperatures are very, very high, they tend to have temperatures ranging between 500 and 2000 degrees Celsius. Wow. 500 to 2000. 2000 means, I don't know what will not burn at 2000. 2000 degrees Celsius. Now here, there's ionization, which we call the ionosphere. There's ionization, where gases are turned to their smallest unit here because of the heat. And there's another layer here you call the exosphere, where air happens to be absent in that area. So sometimes they will ask, the part of the atmosphere where air is absent is termed as, it is not thermosphere, it is not ionosphere, it is not troposphere, but it's exosphere. It is a portion of the thermosphere, but that portion of the thermosphere do not have air. Air tends to be absent. Air tends to be absent. That is the thermosphere portion that I want to talk about. Then from there, the atmosphere joins the sky. The skies is different from the atmosphere. When we're defining atmosphere, we say where there is air, gas, the thin gaseous layer that envelop the earth. So if they are not able to get gases there, then it means we have gone to what we call the skies. So the atmosphere is just something small. Because the distance between the earth and the sun is about 150 million kilometers. 150. And that 150 million kilometers the maximum you get for atmosphere is 100 kilometers. So you take 100 kilometers from 150 million. We have not even gotten quarter of it. Meaning space is wider and longer than the atmosphere. All right, that is fine. Now, with that of the composition of the atmosphere, we say the atmosphere is broadly divided into two main layers. In terms of what it is composed of, it is broadly divided into two main layers. The first one is homosphere, and the second one is heterosphere. Homosphere and heterosphere. So where we have mixture of constant gases in the lower portion of the atmosphere is called homosphere. And the higher limits where gases tend to be going down, where there's a little missing, and where there's diffusive separation, that place is what we call heterosphere. So the lower portion of the atmosphere is the homosphere, where gases happen to be constant. And the upper portion, where gases happen to be reducing, is what is termed as the heterosphere. So broadly speaking, the atmosphere, in terms of its composition, is divided into homosphere and heterosphere. The lower layer, where gases are constant in terms of its composition, is termed as homosphere. And where gases begin to vary, the upper limits is termed as the heterosphere. Now, in the atmosphere, there are some known gases that we call them aerosols, or you see aerosols. You have the aerosols, and the aerosols are made up of organic matter, the salts, the dust, and also smoke. And they are very, very, very important for the formation of rainfall. Any question up to this point? Any comment up to this point? Hey, go ahead.
Sir, with the composition of the atmosphere, your line was breaking, so I didn't hear anything from there.
Thank you.
Thank you.
Madam Ajiman.
Sir, please, will you take the aerosphere again for me, please?
All right, thank you.
Welcome, thank you.
So I will start talking about the composition of the atmosphere. And we are saying that the composition of the atmosphere is broadly divided into two, which is the homosphere and the heterosphere. The homosphere and the heterosphere. The homosphere is the lower portion of the Earth or the atmosphere where the gases tend to be constant. The homosphere is the lower portion of the atmosphere where air or gases tend to be constant. So where you have maybe carbon dioxide 0.0 something, correct? Where you have oxygen 21, where you have nitrogen say 78%, and it is not reducing that much. It is termed as the homosphere. But the heterosphere, those ones are the up ones when you move upwards, where the gases composition tends to vary or tends to reduce. That is the heterosphere. And those ones do not happen within the troposphere. Because we say within the troposphere, all the gases, about 99%, all of them, they are in their rightful proportion. That's about the troposphere. Now, we say that because of the ultraviolet radiations, the rest all happening in the atmosphere going up, the gases tend to reduce as we move higher. For example, when we're talking about the mesosphere, we said pressure can go as low as even 1% as compared to the one at the sea level. That is that. Now, taking away that, then we talked about some gases in the atmosphere called non-gaseous constituents. Non-gaseous constituents. And we cannot find there in the upper part of the atmosphere. For example, we go to the troposphere and the thermosphere, mesosphere, or the stratosphere, and you see smoke. No. You didn't see smoke, you didn't see dust. There's no dust up there. The only dust particles that you have are found within this troposphere. So the non-gaseous constituents are only found within the lower portions of the atmosphere. And these are particles such as dust, smoke, salt, and others that are very important, deeply, very, very, very important. Because these help form hygroscopic nuclei. They help in formation of rainfall because they help form the eye of clouds, which give us rainfall. So the aerosols are non-gaseous gases that are found in the lower portions of the atmosphere, and they are dust particles, smoke, salt, and others that help in the formation of rainfall. All right, any comment again?
Sir,
Onward Christian soldiers, go ahead.
sir, please. So I think you said this earlier on, but the network. Sir, please, what are aerosols? Sir, hello. Sir,
Are you speaking?
hello.
Are you speaking? Yeah, hello.
Yes, sir. Yeah, sir. Please, I was asking what aerosols are. The definition. What are
Oh, okay.
aerosols?
Okay. When you mention aerosols, we are talking about suspension of some fine particles that we have in the atmosphere. Fine, solid particles. So they are fine, solid particles that are found in the atmosphere. Someone will ask, why then do we have smoke? After smoke have been around for a very long time, if you touch your body or if you wipe your body with something, you see some particles there. Salts. When you go to the seaside and after you have stayed there for too long, touch your body and try to smell it or even taste it, you feel that you have a lot of salt on your body. For dust, I wouldn't comment because you feel it in and around you. So aerosols are fine particles, solid particles. Please, are you fine?
Yes, sir.
Okay.
Sir,
Yeah.
So the aeroplanes that we normally see in the atmosphere, so that place is the stratosphere, right?
Okay, that's a very nice question, but I'm not too sure. You see, where our eye can see, we can't see the the stratosphere. For the stratosphere is very far from us.
Okay.
We are talking about something that is above 8 kilometers into the atmosphere higher. And I don't know whether your eye can see about 8 kilometers above.
No, sir.
Maybe you're a magician, I won't doubt you. Maybe too, you're like me that you move in the night. It's fine. Yeah, but one thing is, we say airplanes like operating there because that place is stable. So they can ask you, why do airplanes operate in the stratosphere? Because of its stability, because the place is stable. But when they are about landing, they can't be there forever. They will definitely come to the troposphere and land. When they are about taking off, they can't just take off in the stratosphere. They must first take off from the troposphere, then find their way through the clouds and get to the stratosphere, then take shape and begin to move. All right, so when you see them and you see them entering some clouds and the rest, meaning they have still not found their permanent place of movement. They are now still struggling to get there. That's why most of the time it is tilted until it gets to that limit. You have not boarded a plane before, so you don't know. Oh, Kofi.
Okay. Hello.
Yes, please go ahead.
Hello. Yes, please. I would like to know where the law of gravity stops working when we talk about the divisions. Where does the law of gravity stop working? Because I've learned that in one of these regions there's flotation. So where actually does it stop and where does the flotation start from?
Please, are you speaking? I can't hear anything.
Sir, please, are you here?
Yeah, but I can't hear you.
Yeah, please. What I wanted to ask is, where does the law of gravity stop working when it comes to the division of the atmosphere? And then where does I learned there is flotation happens in one of these regions? Please, where does it take place?
If I can hear what you said, we are talking about the law of gravity, where it ends or it failed to operate. It moves through, if I heard you, it moved through the layers of the atmosphere till it gets to somewhere space. But space, specifically which level, that I can't tell, but it extends up to space. I mean, it passes through all the layers of the atmosphere. The troposphere, the stratosphere, the mesosphere, and the thermosphere before getting into space. But I hardly hear what you are saying though. Okay, any other question?
Yes, I have a question. I wanted to know, I was just wondering, before astronauts started going into space, how did they first realize that beyond the thermosphere there is no oxygen, and for that matter, they need to carry along um, with oxygen, something like that? I was just wondering, how did
And
they
then continue
realize
to
that?
wonder. Yeah, because that's where learning began. So maybe if one person went there and died, or before they go, they might have, taken some photographs and the rest. So they experiment. And always through experiment, people die. Or people get confused, people, go mad and the rest. Then they develop and build on it and build on it. Look at the first airplane that we have. Look at how it was. Balloons turning into so of your right. And so anytime there's experimentation, something bad will happen, or perhaps something that is not too meaningful will come out before they build on it. So out of curiosity, so many things will come up and they will be able to, come out with something meaningful like we have now. So we all continue to wonder what happened. Because we still wonder why in the olden days, if your wife was not giving birth, they will go and bring another man. If they still think you are failing, they will bring another man to come and have something with your wife to give birth. Why didn't they go ahead and say, oh, let's go for your egg? Because it's not about the sex they need, it's just about the egg. So why don't you just go for the egg and give it to the woman through artificial ways and give birth? I say, oh man, come and enjoy him. Oh, sorry, come and enjoy her. So, in the quest to get knowledge and the rest, it is like that. Sometimes they feel, they wonder, curiosity, then they're able to come out with some of these things. So the scientists are best to answer some of these questions for us. We are just geographers. And very soon, maybe you invent something that will be meaningful to us. Yeah, Mr. Oh, yeah, Honorable Atanga.
Yes, I'm okay with that.
All right, thank you. St. Francis 254. Eja Innocent, please let's hear you.
Sir, please, I've been hearing something like when we were in SHS, they used to say that there is this portion of the atmosphere where moving objects, let's say the aeroplanes and other moving objects, when they get there, they can equally disappear. And they have been calling it the Bermuda Triangle. So I want to find out if it is true or not.
All right, thank you. I love this question. I've also heard it, but it's not part of the structure of the atmosphere. But one thing is that it is found from sources. They are found in the sea, most especially the deeper part of the sea, and it has a direct link with that of the atmosphere, where it draws object to itself. That's all I can say on that.
Okay.
All right. Asante. Asante, please speak. Ajay, are you there? Ajay Steven.
Yes, sir.
All right, so take charge of the discussions. You are the leader now. You have 5 minutes.
Okay, sir.
Okay, how about take charge? I think he can't get me. Where's Edu?
Okay, colleagues. So where you've gotten any question or any contribution? Yes, I hope you can hear me.
Yeah, please, I was asking something concerning turbulence, which is associated with a plane, and what causes the turbulence in the atmosphere.
Okay, any other question? Any other question, colleagues?
The network is very bad. The network is very, very bad.
Okay. Victor's. I saw a hand up, or it was a mistake.
Yeah, I said it.
Oh,
No, it
okay, the
wasn't a
network.
mistake. The network is very bad.
Yeah, the network is very bad today. All right. So if there's no question or contribution, say he's asking the turbulence of the atmosphere. Please, if any of us can help him, please let's help him out.
Yeah, turbulence in the atmosphere are mostly caused by the weather irregularities. So anytime the weather is not stable, it tends to cause those irregularities in the atmosphere. Then they cause the turbulence. Because there's a course which I don't know whether you do, it's called climatology. Those ones are well explained there. Maybe if you to get there, we'll be able to explain them more. When you see at any point in time, the air or the weather can change at any point in time. The weather can change. You can't predict the weather. Because the air or the wind keep moving here and there, and they keep changing their direction here and there. So you might have got a pattern that you use or use all the time. Potholes in the atmosphere. Oh no, they are just weather changing direction. Weather how do you call it? Weather irregularities. When something is irregular, you understand the term irregular, which is not happening or forming the same pattern that it used to be. But when there's a change in it, which become unusual in the atmosphere, when the planes get there, they're able to get that turbulence. And some of them are very, very severe and dangerous. But no, they will tell you, don't panic. It is normal. Tighten your seatbelt. That's what they will tell you. But it's not any pothole. Yeah. Where sometimes shake a bit is when you are trying to enter clouds, when you have not even settled in the stratosphere. You feel that there's some boom here and there. That's when the plane will be shaking and you say, hey, am I safe? Yes, you are safe. But the up there is about irregularities in the atmosphere. That's all. When it happen like that, the pilot might either go a bit lower or a bit higher than where it is having that irregularity. Then you become stable. That's how it is.
Thank you, sir. Any other question? Colleagues, any other question? Okay. Prudence, your hand is up.
Please, which of the layer do we find a cloud?
The clouds are found, just like I said, in the troposphere, the first layer. So it rains only in the troposphere. When you go above the troposphere, there's no rain. So no one will tell you that when I board an aeroplane and it was in the troposphere, in the stratosphere, it's rain. No, all you see is white surface. The sun is shining. That's all. You don't see anything. The whole place is white, and that is it. There's no rain there. The rain only happens in the troposphere.
Okay, thank you.
Thank you.
Okay. So any other?
Sir,
Okay.
sir.
Yes, Steven, please talk.
Hello. Sir,
Uh,
please, with my, sir, the last time you promised to send the course outline, but you didn't send it, so please. After the class, kindly send it to us, please.
Okay, since there are no other questions or deliberations, so now let's see how they go. Let's, oh, how about thank you, sorry. We
You're
want to
welcome.
continue. Yeah, I'll pay you, right? Don't worry. Thank you. Now we're talking about the composition of the atmosphere.
But so please, you didn't communicate mine.
And we are saying that for composition of the atmosphere,
Sir, please hold on. Sir, please hold on. Mr. Steven, please, what did you just say? I didn't communicate to yours. Okay, sir. He was saying last time you promised to send the slides, but he didn't hear from you.
Is it sure I didn't send him the slides?
It is the course outline rather.
Sir, the course
outline.
Yeah, you said you sent me the course outline, but I didn't.
Modified one, unified one from the course coordinator. I've not received it yet. That's why I should not give it to you. Because the last time I called, we said we are using the topics that he provided, but the materials on it and the rest, he has not developed it as to which materials you should read, but that's the same content you should be using. So I asked that he develop new one so that we all use it as one. And said for now, we should use his material as a guiding material for the course as he prepares the course outline.
Okay. Okay.
All right.
Okay, so sir, please, in the comment section, someone is asking, Lawrence Boa is asking, in which layer does lightning happen?
What is your take on that?
Sir, please, I want to contribute.
That's fine. Thank you, my dear. I love you. Okay, go ahead.
It happens in the first layer where all weather conditions occur. That's the troposphere. Thank you.
Thank you, Shuda. See you continue.
Lawrence, have you been answered? Okay, okay. He has given us thumb up, so I think we are good to go. So please,
right.
let's continue. Thank you.
Thank you. Because you didn't answer that question, what's going to happen is that the payment will be slashed by half.
Okay, I accept.
Thank you.
Thank you.
Now, we have the composition of the atmosphere like we have talked about, and we have a table depicting or showing very, 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 very detailed, detailed composition. So we will want to mention the first six gases. And I will call on my honorable Stephen, to do that for me. Okay, Ibrahim. Okay, Prudence.
So we have nitrogen. Hello.
Please, we are all listening.
Please, I'm to mention the first six.
Yeah, the first six. And their percentages.
Oh, okay. We have nitrogen 78.8. We have oxygen 295. We have argon 0.93.
Okay.
Carbon dioxide 0.3. Then water vapor, highly variable. Then we have the ozone 0.2 to 10. So what is the ppmv? Then we have the
That's a unit in which it is measured.
Okay. Then we have the neon.
Okay, so all right, thank you. Steve is still not being around. Okay, Prudence will take charge. Ask which one is the highest and which one is most important and their importance. The first six.
Okay. So colleagues, looking at the table, the first six, which one is the highest in volume? Yes,
nitrogen has the highest percentage.
Nitrogen. Okay. So which one is the most important among the six? Victors.
I think we say the can't hear you.
Hello, Victors. Victors, we can't hear you.
Can you hear me now?
Your voice is down.
Oh, can you hear me now?
Yeah, we can hear you. Hello, Yusuf. Emmanuel.
Please,
Okay.
did you ask
Almost all
about
of
the
them are
most important component?
That's what I'm asking, and we couldn't hear.
Oh, for me, I would say oxygen.
Victors. Okay. Why?
Okay, so you see, the oxygen is the gas required for respiration. Yes, by all living organisms on the earth, from humans to bacteria. So I would say it is oxygen.
Oh, okay. Emma.
Thank you.
Welcome. Emmanuel.
Please, I've responded to your question now.
Okay. Owusu Abuaje. Prince. Sir Prince, your hand is up.
Yeah, I would say it's carbon dioxide because it is
Okay.
plants that, and then these plants will need carbon dioxide to be able to survive. So I would say carbon dioxide.
Okay. Victus, your hand is still up.
Yeah. Can you hear me?
The line is breaking.
Can you hear me?
Yes, please.
Oh.
No, I can't hear you.
So,
Sir Victus, we can't hear you. Yao.
carbon dioxide is the most important one.
Okay.
The most important element is the oxygen, because without it, human cannot live. So the oxygen is the most important element there.
All right. Thank you. Okay, sir.
Fair play. I also
Thank
support fair
you.
play as being the most important.
My worry is that people are thinking some of the gases are important, the other. That's true anyway, but well.
I will also go for the ozone as it protects or it traps the ultraviolet rays coming from the sun, thereby protecting humans from being burned or something like that.
Okay.
Is Ibrahim there? Who is there? Edu, are you alive now? So that Prudence will rest.
Yes, sir. I'm here.
Oh, Ibrahim.
Edu.
Okay, so let's now discuss the importance of nitrogen, oxygen, carbon dioxide, water vapor, and ozone. Quickly. Take charge.
Okay. So, colleagues, what are the importance of these gases? The gases just mentioned. What are the importance, please? Please, I'm waiting. Okay, yeah, I'll say it too.
Please, the question.
One important of nitrogen is that it is a nutrient. It's one of the major plant nutrients that help plants to grow well. So we have, yeah, please can you hear me? Hello?
Hello, we can hear you.
Yes, I
Okay,
can hear you. Yes.
I was talking about the importance of nitrogen. And I'm saying that it is very important because it is one of the nutrients, one of the major nutrients that help plants to grow well. And without nitrogen, most of the plants cannot grow well.
Oh. Okay, thank you. Yeah, Emmanuel.
All right, so I would want to talk about the oxygen. So the
Emmanuel,
oxygen,
please talk.
yes, the oxygen is required for respiration, that is breathing. Yes, and it is needed by man and then other living organisms on the earth for their survival.
You already.
Okay. Yeah, Vitus, please.
Yeah. Um, I would like to talk about maybe the carbon dioxide. Can you please hear me? Can you please hear me?
Yeah,
Yes.
I can hear you.
Yeah. So I would like to talk about the carbon dioxide. It's the last one. We said something earlier that when we look at the trees, they need carbon dioxide so much to prepare their food, which we
Yes.
always call photosynthesis.
Yes, please speak up.
Yeah. So carbon dioxide is important for photosynthesis as in plant survival, because when they survive, in a way, they give us back the oxygen we also need as well. And then when they survive, they give us food as well. There are other things they give us. So carbon dioxide is very important to aid in photosynthesis of plants. And also make them survive. In their survival, we also survive, because let's all remember that when the last tree dies, the last one dies, and that's not submission.
All right. Thank you. Francis.
Okay, I'll also talk of water vapor. So I'll say water vapor, one of the important is that it causes rain, cloud, and humidity. I understand the
Okay.
importance of the vapor. Thank you.
All right. Thank you. Jude. Judith, please.
Okay, so I also talk about the nitrogen.
Judith.
So the nitrogen helps in preserving some food crops that we take. So it's also very important, like potatoes and the rest.
Okay.
Hey, those that like food. Yes, see you.
Thank you. Prudence.
Yeah, I'd like to talk about the ozone layer. The ozone layer. Yeah, I'm there. The ozone layer. The ozone. It absorbs the ultraviolet radiation from reaching the Earth's surface.
Okay. Thank you. Crispin. I don't know whether that's the correct thing.
Okay,
Crispin.
so I also talk about the water vapor. Yes, you are correct. The water vapor helps regulate Earth's temperature by trapping heat. So water vapor helps regulate Earth's temperature by trapping heat.
Okay.
Yes,
Okay.
Mohammed,
Yeah.
Can I go ahead?
Yeah. Please. Okay. Go ahead.
Okay, so another crucial
Francis.
role that carbon dioxide plays in the atmosphere is the absorption of infrared radiation that makes the air warm, that supports life. So that means that if that was not, that is what we call a greenhouse effect. If that was not happening, that means that the earth would have been so much cold. There would have been so much cold that it would have been difficult for us living on the earth. So carbon dioxide absorbs infrared radiation that keeps the earth warm to support life.
Okay. Thank you. Judith. Judith. Okay. Sir.
Yes, boss.
Sir. Yeah. So, sir, from their submissions,
Well, some are saying they are the carbon dioxide is good for photosynthesis, and some also said nitrogen, that is, it being a major component on the Earth's surface, so it helps. It is a plant nutrient, and others are saying that the um, hydrogen. Say, please hold on. So, and so others are also saying that the H2O also help, and it causes rain. And some said the nitrogen level. And Prudence also spoke of the ozone layer, saying it absorbs the ultraviolet rays from the sun. And Crispin also was the H2O help to regulate temperature. Please, Prince. Yeah, Crispin, do you have anything to say
Yes.
again?
So I'm trying to say that I was trying to say that the nitrogen helps in the
Hello.
preparation of fertilizers.
All right, that's fine. That's very, very good. That's good. It seems Edu's network has become like
That is
something in my
NP.
hometown. MPK what? 1515 or 2020?
Yes, NPK.
Yeah.
All right. Yeah, I do. Edu,
Okay,
thank you. Your
so
network is not helping too much, but
that
you
is
have done
all
very,
that they
very,
said.
very, very, very well.
Regulating
Let
of
me
the
continue.
temperature, absorption
Thank
of
you.
ultraviolet ray.
So now one thing you should understand is that I asked this question. Are you aware carbon dioxide is used in making this your the fuzzy drinks? That's the first question. Are you aware carbon dioxide is used in making these fuzzy drinks? The Coca-Cola, the Bola, the Huan Huan. You are aware, Amwa? Thank you.
Please,
Are you aware? Also, are you aware?
Okay.
All those who are aware, just give me thumbs up.
The carbonated drinks.
Thank you. That I didn't want to use carbonated. I was just trying to brothelize it.
Easy drink.
Okay.
Oh, okay.
So the interesting part is that the carbon the carbon dioxide that people said you don't like, so you breathe it out. I don't know how you manage to get it inside your body again.
Wow.
Even though that one is, what do you call it, lab made, but it's still carbon dioxide. No doubt about that. Please, I'm not confusing you, Judith. You can take it. I don't care. They serve as preservative, but one interesting thing is that Kineben is true. They preserve it, but don't forget they also give it taste. If you like, just go for Coca-Cola 1 bottle and use the straw to hit it several times for all the fumes or whatever the foam should go out. Let them go out and see whether it will be tasty. It will be tasteless. You have tried that before, I believe so. If you open Coca-Cola bottle for a very long time, is it tasty? No. Yeah, it's no. So the fizzy drink that, carbon dioxide is air, good, but it's used to preserve food. At the same time, too, it is used to make food tasty. If you open the Coca-Cola, wow, happy you go, you are dying. You don't know. Oh, wow. Why? Yeah, that's it. That's it. Yeah, Coca-Cola. It's better to take the fruit drinks yourself rather than going to buy these fizzy drinks. All this. Oh, you are not killing ourselves. Or we are killing. Yeah, we are killing ourselves. That's true. We are killing ourselves. So we have to be mindful. We are not saying don't take them, but like I always say, take them in moderation. I believe that one Abba will like that. Prudence will like it. We are all okay. Take them in moderation. Thank you, Emmanuel. Yeah. Let's take them in moderation. If you can stop, stop. If you cannot, please let's take the moderation, because carbon
shall miss
dioxide in
you.
itself is no good.
Because
Mary, please, you are speaking, speak.
so it can harm you. Huh? Yeah.
It will harm you.
Yes,
But it's
sir.
better to take it once a while. Yeah.
Yeah.
Prince, please, you want to speak? Oh, you dilute it with water. Massa. Augustine, be careful. Okay. And we say water vapor is important. I like the fact that I say it's important because it's helping, formation of rainfall. Very good. It also helps in moderating the temperature. Sometimes the temperature is too hot in an atmosphere. As soon as the rain begins or the temperature change, you see that the temperature will be going down. So water vapor is very, very, very good. When the temperature in the atmosphere is very moist, when there's water in the atmosphere, you feel that the place is not too hot. So one work of the temperature, what they call it, the water vapor. Carbon dioxide, I don't know why no one mentioned that it makes the atmosphere warm. It is the carbon dioxide that makes us be able to be comfortable to stay on this earth. Yes. It makes the atmosphere warm. When the sun strikes the earth, that is when the carbon dioxide in an area, strike it and is able to give us heat.
Oh, I made that submission.
Oh, then sorry, I didn't hear that. Sorry. Yes. So please, they are all important. They are all important. They are all important. They are all important. All right. Thank you very much for that, your submission. I thought today your class, you wanted to make it boring, but you've come up to light. That is fine. All right. So what we said, that's about 3 of them very, very strong. It's here. That we said the atmosphere, we have this. Nitrogen is there, carbon dioxide is there, the argon. Argon is just a dry gas, but it's found in the atmosphere. But you see, the unfortunate thing is that carbon dioxide is 0.03. But I still look at the way we are feeling hot. What is happening? Has the percentage changed? Carbon dioxide is just 0.03, which is not even up to argon 0.9.
No, sir.
But we are suffering.
Sir.
Go ahead.
Sir, please, the ozone layer is depleted.
Okay, that's fine. But we are told there are some potholes in it.
Yeah.
All right, that's okay. Now let's see. Now you have major gases in the atmosphere. For aerosols, we have talked about it. The major gases, we have talked about them. The major gases are the one that we have mentioned so far. Then the oxygen, the argon, and the rest. Then other important. Please, an examiner can ask you to talk about the gases in the atmosphere for 20 marks or 10 marks. An examiner can ask you to talk about these gases. So for the gases, I will try and send them to you. Then radiation and heating. Radiation and heating. This portion is very, 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 very important. If you are tired, let's pause. If you are okay, let's go through the heating. So let me get feedback from the class. I don't teach alone, I teach it to my group. The feedback tells me what you should do. Okay, that's one. That is just one submission.
The class is interesting. So let's continue.
All right, Elijah and my colleague, that says you should continue. Let's just finish with this, then we close. Now, we have just said that the atmosphere has some gases. That is good. But the atmosphere, one gas that it receives, that gives us the heat. So we say the sun is called the solar insolation. That energy from the sun is known as solar insolation. Or people simply say insolation. So insolation is the sun energy that we receive, or the energy from the sun is termed as insolation. Now, one interesting thing is that the sun, which heats, does not pass through anything. It just passes through a normal space, vacuum, and just come to us. It's just like you have thrown a light. It is not passing through any channel. It just uses the main space and come to you. And that's how the sun travels. But we are still able to make it get to us. One book I read told me that the sun takes about 8 minutes before it gets to the Earth's surface. When it shines, take about 8 minutes before it gets to the Earth. I'm here to confirm its authenticity, as whether it is true or not. I say when the sun shines, it takes about 8 minutes to get to the Earth's surface, which is either true or false. Now we have 3 means by which there's heat transfer, means or forms of heat transfer. Means or forms of heat transfer. We have 3 of them. We have the one in fluids. We have one by actual contact and in metals. Then we have one that occurs just through space. Which one will you want to talk about?
Talk about the one with true fluid.
True fluid? So that one I should take it and so that you take the rest.
Oh no.
Yes. No. Say take all.
All right, if I'm to take all, I will take all. And the other one too, I will take all. You know the other one I'm talking about. When it comes to giving you question areas too, I will tell you I've taken all, so I won't give you. All right.
No, sir. No, sir.
No, sir. All right, so now let's see.
We will talk.
Oh, I know you have been talking. I love the way you've been talking. If I say don't talk, rather be unfair. Now, when you want to talk about conduction is the transfer of heat through objects. It's a transfer of heat through objects where there is what we call contact. Where there is contact. So with that contact, there's no conduction. Bam. If a metal is there and you have not held it, how will you know there's heat passing through? Until you hose it, until you contact it, that's when you see that there's heat transfer. So it involves the transfer of heat energy from one substance to other, or within substance due to heat transfer energy from molecule to molecule or from atom to atom. So what we want to say is that when there is contact, then it means there's conduction. Heat transfer through objects by contacts is conduction. Heat transfer by conducts or by contacts is called conduction. So you hold the metal and you feel the heat. You can hold the other ends, but still heat will pass through to the other side because you have touched it, because you have your body has touched it, or because of the fact that there have been a contact. That's why the heat is passing through. But the second one is what you call convection, where there's heat transfer in fluids, which other people call it in liquids. It takes a very long time before convection will occur. It takes a very long time before convection will occur. For convection, it is when heat moves or heat transfer occurs in water bodies. So sometimes you put water in the sun, in a barrel or in a basin or in a bucket when you want to go and bath. Those is when we're in village, that's what we're doing. You touch the water, the surface, it will be warm, it will be okay for bathing. But as your hand gets to the down part of it, you see that still the place is cold. So what do? You mostly mix it with your hand and later come back again. That means heat transfer in water, which is called convection, is very slow. Very, very slow. So heat transfer by contact is conduction. Heat transfer in liquids is convection. Heat transfer in space is called radiation. Heat transfer in space, which you call electromagnetic spectrum, in space is termed as radiation. Okay. So these are the three heat transfer forms that we have. So the energy from the sun is called solar radiation or an insolation. And when the insolation get here, what happens? When the insolation is coming, it is transferred in three ways: conduction, convection, and radiation. So the radiation is a process by which sun rays are transported or transferred from where the sun is hitting or where the sun has started from the sun to the ground. It travels through what we call electromagnetic waves. It travels through electromagnetic waves. And the spectrum or the space that it passes through is termed as electromagnetic spectrum. So in which medium does the sun travels through radiation? The answer is electromagnetic spectrum. How does the sun get to the Earth's surface? It travels in a wave called electromagnetic wave. Or they can ask you, in which energy, which form of energy does the sun travels? Electromagnetic wave. So these are the three forms of radiations, so the three forms of heat transfers that we have. One is by liquids. One is by liquids. One is by contacts through objects. The contact by objects, such as the ones that are conductors or good conductors, like metals. Even wood is a conductor, but a bad conductor. It takes a very long time before it passes through. They are all part of it. Then, so we have conduction, convection, and radiation. By contact and through conductors, by convection and through liquids, by radiation and through electromagnetic spectrum. These are the three forms of energy transfer that we have. But one interesting thing is that the sun that we see here on the Earth's surface, when it's coming to this Earth's surface, some of them are absorbed, some of them scatter, some of them also come to the Earth's surface. Some of them are absorbed, some of them get scattered, some of them are able to get to the Earth's surface. So like we have seen what you call the total solar irradiance. That is the average intensity of solar energy reaching the top of the atmosphere directly facing the sun. In other words, the amount of power from the sun to the earth is known as total solar irradiance. So the one that do not hit anything, the one that just comes straight, is termed as total solar irradiance. So the amount of solar radiation, the overall maximum that we have, is the one we call the solar irradiance. Now, one thing we should understand is that the sun hits the Earth's surface at different angles. The sun hits the Earth's surface at different angles. If you can see the picture on the screen, representing that of the solar, the Earth and the sun rays coming to the Earth's surface. Now we have the middle here, I call A. I have the other part I call BB. You realize that when the sun is coming, it takes a shorter distance to get to A. But when it is going to B, radiate, very long distance before you get here. That is why Ghana and the tropics, we are always having high amount of sunshine. Because we are always found in between here, the middle here. So as soon as the sun begins, it gets to us. I think there's a question or there's a comment up there.
Yes, sir. Sir, please, about the solar radiation and the sunshine. He said some aspects, others are absorbed, some also get to the Earth's surface. And you were explaining how the movement and how they get to the Earth's surface. Can you please come back again, please? I beg. Thank you.
Yeah, that's fine. One thing I have to make clear is that out of the total 100% solar radiation, only about half out of 100, only 50% get to the Earth's surface. One, some of them are absorbed. If you remember, we mentioned something you call ozone. It prevents some of the solar radiation from coming to the Earth's surface. Apart from that, some of them are redirected, which is reflection. Some of them are reflected. Others too are scattered. For example, the blue skies, they scatter the radiation. Yeah, 15 puni, we have been saying it's even getting less. So because of the reflection, absorption, and the scattering, only about 50% get to the Earth's surface. So if none of them is being absorbed or scattered, it means all the 100% would have come to the Earth's surface. That is that. Now, when the 50 or so have got to the Earth's surface, when they are coming, portions of the Earth receive more sunshine. Portions of the Earth, different, receive different amount of sunshine. Now, like I was saying, this is A. This is A. A and B, they all receive sunshine. Don't forget, there's absorption going on. There's scattering going on. There's scattering, reflection going on. So when the sun travels from where it is to the Earth, those at the middle portion of the Earth will receive more sunshine. Because the sun can just straight, bam, and you are here. Look at the distance it will take. From here, it has started to the portions where they are the angles. They will take a longer distance before they get there. Therefore, those polar regions, last time we were talking about it, receive less solar radiation or insolation. But those are the polar regions like Ghana, Nigeria, Congo, Liberia, and the rest. We receive more sunshine because we are found in the tropics or in the equatorial zones where the sun hits directly here. Here, the scattering will reduce. The reflection will reduce. What else will reduce? The absorption. But here, by the time we get here, most of them might have been absorbed, reflected, or scattered before they get here. So Ghana, we have more sunshine. Now, what happens before those things are scattered? It depends on what the atmosphere is made up of. When you have more clouds, more snow, and more water droplets in the atmosphere, much of it is scattered. So we say about 29% of solar radiation arrives at the top of the atmosphere, is reflected or scattered because of this clouds, atmospheric particles, brighter grounds like the sea and snow. About 29% is either reflected or scattered. And because of the higher traveling distance, most of them are reflected back to the space. We call them back to sender. Now, there's a term I like most. People call it albedo. I call it albedo. Albedo is what? Albedo is the fraction or the portion of the solar energy that is reflected back to space by the surface. So the surface which reflects the energy that is taken back to space by the surface or by any surface that we have is called albedo. So albedo, energy that is taken back, is albedo. Now there's another one we call diffuse radiation. Diffuse. The diffuse radiation is the solar energy that is able to pass through clouds and find its way to the Earth's surface. Sometimes, let me ask you, sometimes you see that it will be cloudy, as if it's about raining. But you see that the place is shiny, but the sun is not too intense. That's called albedo. I'm sorry, that is called diffuse radiation. Diffuse. It has been able to pass through the clouds and come to the Earth's surface. And that one, I call it diffuse radiation. But albedo is the one that is sent back by space, reflected back by space. It's called albedo. Now, we say about 28% is also absorbed. About 23% is absorbed. About 23% is absorbed. So this tells us that even though the sun has been coming and coming and coming to the Earth's surface, it is not all that get to the Earth's surface. Now, from this source, we have been saying less than 50% get to the Earth's surface. Look at it. We have absorbed 23%. Another absorber to come closer, 48%. 29 reflected and scattered. Don't use this to make calculation. Why? Why? Because when the 23 is taken back, it is gone. But the others that will still come down, it get here and 48%, making 100, also goes back. So when it get here and the 23 is taken back, the whole thing tends to be 100% again. Those have done maths before, you understand. It get here and about 40% also take back. So at any point in time, portions of the solar radiation is taken back. The conclusion is that the total amount of solar radiation from the sun does not get to the Earth's surface. Portions of it are reflected, portions of it are scattered, portions of it are absorbed. Good afternoon to you all.
Good afternoon, sir.
Good afternoon. Good afternoon, sir.
Good afternoon, sir.
Good afternoon.
All right.
Good afternoon, sir.
Now, what have you learned so far?
Good afternoon, sir.
Yeah, awesome.
Oh, sir, man.
Yours was late. All right, Manfo. Hey, Ibrahim is back today. I see.
Oh, sir, David, I'm
Maybe
back
you
last
went to
week.
the mosque. Hey. But today I've not seen you. I've been calling you. I don't mind me.
Oh, sir, it's not. I went to a certain outdooring. My uncle's outdooring.
That's okay. That's okay. That's okay. It's fine. And you're a big man. Enjoy.
Stop
stop drinking carbonated drinks.
Oh, I'm not taking them.
Okay.
Me share. Ekum papa nu ebi ntimi me carbonated drinks.
Very good. Say, I was asking, say, those who are around the desert area, you could see that the sun scorch very high at that area. Have they made any calculations of the radiation that goes through there? Say, if you like that one.
Please, so.
Says now, says gone on.
Yeah, free so.
Yeah, says gone.
Amwa.
What?
Boy,
Yeah, so-
Amwa.
I'm here.
You said we should stop drinking it. So what about Ima ask strawberry
Strawberry carnival.
Hey, sorry.
Charlie, all of them are no good, though, Charlie. All of them, they contain some preservatives.
So
me sure say carbonated drinks. Maybe we say rather medicine because Guinness and the rest are not carbonated. Charlie, ni na nye munja.
It is over there.
I know that me sure I don't know can one voice in the brain and that man no if I can say
Hey,
Monum sobolo. Monum sobolo na sobolo ja sa no.
Charlie. Because you nice so. But also we are creating more space so. Cosmic race. So they create more space. About the extra more friends say. We more. But nice course.
Grace.
Hey, let's say what in fact.
Kwame say
Kwame said.
So how can I change my saying so the I flat? Me they say I
can say
their stomach as I'm go to corner hit gym.
You could start to learn A B C D here.
It's not bad, that's fine.
Hey.
Oh, it's normal. It's normal. Okay, that's fine. That's okay.
Hey.
Oh, you're interested in the carbonated drink, wow.
I want that.
Because you want to stop Prudence, Mary, Dixon, Schroeder, and the rest from taking their favorites.
Yeah.
They want to stop. Or die. Take it off. Or die.
Yes, they want to discourage me.
Or die. All right. So now, colleagues, we are all colleagues here. I believe we can say we have learned something small today.
Yeah.
Okay. If we have learned something today, then I will request that if you have any questions for me.
If we have any question or contribution.
Yeah, questions first before contribution. Yeah. So I was asking, say, those who are around the desert area, you see the sun scorch very high there. So how come? Because and then you made mention of 8 minutes something. So does it go through that range? Say more desert areas and so because I'm not sure. Say those who are the desert area will receive the same radiation of the sun as compared to those who are somewhere around the sub-Sahara, like Ghana and then the rest. All
Yes.
right.
And then he said that those places are nearer to the equator.
All right. You
The
see,
sun
one thing is
radiation.
that for you at a place to receive a solar radiation
Yeah.
or the amount of sunshine, it's not dependent on just one factor. If you ever did geography at the SHS, I was teaching geography at the SHS before moving to the tertiary. We're teaching it there. We say factors influencing amount of solar radiation an area receives. So we say that location counts. There are some places where there's no clouds at all. For example, in the northern part of the country, which we call it cloudless sky. Cloudless, meaning there's less clouds. When you have less clouds, what it means is that when the sun is coming, there wouldn't be any clouds to absorb it or to scatter it. Therefore, it comes to you straight. The next one, if you don't have anything like forest, if you don't have anything like forest where the sun will hit on it and be scattered, it will come to you straight. Apart from that too, like I showed you from the diagram, it depends on your location. If you're located at where the sun comes to you straight, you suffer. They're also talking about the next one, altitude. The higher you go, the cooler it becomes. So if you're on top of a mountain, what it means is that the place you receive less sunshine. That's what people don't understand. I'm on top of a mountain, but my sunshine there is less. How? It's because of the term you call the higher you go, the cooler becomes, normal lapse rate, which I've talked about it. And we say the earth is warm from below, not above. The sun that is coming from the skies, it doesn't hit anything until it hits surface. So even though it will pass through on top of the mountains, it will not hit there. It will take the heat from the ground before it travels upwards to the top. This one, I think you must pay me because this is climatology, not for this course. That's okay. Any other question? Those who do climatology will talk more about that one. Okay, now contributions of what you have learned today. Who is taking charge? Who is taking charge? Who is taking charge? Is Mary alive? Not yet. Is Sula alive?
Yes, I'm alive.
Okay. Go ahead.
For my discussions, forms of heat transfer, that's where I'm starting from. We discussed about the three forms of heat transfer. The first one, conduction, convection, and then radiation. Then we said that the conduction is the transfer of heat by actual contact. So where we can say there is a good conductor of heat. Example, we talk about metal and then wood, and then it is very effective method of heat transfer. However, air is conductor. However, air conducts heat poorly. So that's it about the conduction. Then we talk about convection, and then we said convection is the transfer of heat energy in a form of fluid. So in a form of fluid, heat is transferred, and this form is known as convection. And where heat transfer in space, we call it radiation. So this energy is called the electromagnetic radiation. Then radiation is the transfer of heat energy through space by electromagnetic wave. So this is where I'll end by talking about the forms of heat transfer. Thank you.
And by calling who to continue?
So I'm calling Ibrahim, please, are you around?
He's at a party.
Yes, please, I'm around.
Okay, so Ibrahim, you take it from there. Thank you. Ibrahim, please, we are waiting for you. Okay.
I said I was about to talk about what you just said, but I have a question for Seb, but you as we go on.
Please, can you ask your question so that if someone can help out?
Okay. I jotted it down somewhere. Let me go and cross check and reference what I have for him. So somebody
Okay.
can take. I'm checking something around there.
So Crispin, please, Crispin, if you are there, let's hear from you. Crispin. Crispin, please, are you around? Okay. Or say, please, you can take us through. Or say, please, if you can hear me and you are around. Hey, Emmanuel. Emmanuel, please, are you there?
Yes, please.
Okay, so Emmanuel, you can.
Please come again.
Please, we are talking. We are about to end the lesson, and then whatever that we have discussed through this chapters, you can give us a review of it. Thank you.
All right. So, I have learned about the components of the atmosphere. Yeah. So we say that the atmosphere is a mixture of gases surrounding the Earth, and so with the structure of the atmosphere, that is, the atmosphere is in layers. So we have the first layer at the troposphere. And so the troposphere is the first layer of the atmosphere. And these are some of its features or characteristics. So we say the troposphere is the densest layer of the atmosphere. And then also this layer supports life. Then we have something called the environmental lapse rate or the normal lapse rates located at this area. Then at this same layer, temperature remains fairly constant. Then we also move to the second layer, which is the stratosphere. So it's the second layer of the atmosphere after the troposphere. So this layer and then the troposphere is separated by the tropopause. So with the features, we have the troposphere that it contains the ozone, which acts as a shield for the Earth's surface. Then we can also say that the stratosphere has an upper boundary called the stratopause. Then we move on looking at the third layer, which is the mesosphere. And we say that it extends up to a height of about 85 kilometers. Then the temperature decreases with height. And we also said that the mesosphere is the coldest region in the atmosphere. So I will end here, then a colleague can also take it from there. Thank you.
Thank you very much for your submission. Thank you. Please, AJ, are you around?
Please, you called me.
Okay.
Crispin.
Okay.
Yes.
Okay.
So I want to talk about the structure of the Earth, and I learned the Earth is geospherical, so it's not a complete sphere or a complete round. It is geospherical. And then when you look at the Earth structure, we have the inner and then the outer core. So when you look at the inner core, that's how you get the crust. Yes. So we have the crust and then we have the mantle. So the crust is the outermost layer, and then it is solid and thin as compared to the other layers. And then we have the mantle. The mantle is made of the semi-solid rock, and then it is the thickest layer and we have the outer core, like as I said earlier. So the outer core is made of the liquid iron and nickel, and then it is very hot. So I also end here, and then someone should also take it from there. Thank you.
Thank you for your submission, Christine. Um, okay, please, are you around? Okay, Obin has raised his hand. Yes, Obin, please, let's hear from you.
Please, can I? Okay, okay. Hello,
Obin,
Mary.
please, we are waiting for you. Yeah.
I'm not
Okay, okay. I am adding something to what
Obin's
Asista
hand is
Mary
up
said.
too. Okay.
I am on the floor. Okay, so as our sister said, through conduction, convection, and then radiation, heat is being transferred, and then that of the radiation, it's the sun's energy gets to the earth through radiation. And I learned that not all of the sun's energy is being or gets to the surface of the earth. Some is being absorbed in the atmosphere, some is being scattered, some is being transferred or reflected back to the sun. And then we came to a point where we got to know that the part of the energy which is referred back or taken back to the sun is called the albedo and other things. I think I want to end here.
Thank you, Obin, for your nice submission. Ibrahim, please, you can
Mary,
take
hold on.
over the man.
Mary, hold on.
Yes. Yes, sir.
All the submissions were good, but you have an adjective to qualify the one that is given by Obin. Hey!
Sronipa.
Yebeshishim.
That's fine.
Oh, Kofi can
Yes.
no.
Yes.
No.
Yes.
All right, go on. You have just 1 minute left.
Obin, please. I have 1 minute, so the floor is yours, Obin, please.
Mary, bow Ibrahim.
Okay, Ibrahim, rather. Ibrahim.
Obin. Hey,
Ibrahim,
Obin, the
Ibrahim, please, your
assemblable.
question and then your submission. Please, your question, Ibrahim, please, your question.
I've just glanced through it. Was some point that I jotted down, and I heard that was when I was at my party. I said, I overheard of. It was talking about the major gases. So the most common atmospheric gas in the atmosphere is nitrogen. It accounts about 78% of the atmosphere. So from there, he said nitrogen is also largely inert, meaning that it does not readily react with other substances to form new chemical compounds. So from there, he also said that I also learned that the next most common gas is the oxygen, which makes up about 21% of the atmosphere. So oxygen is required for respiration, as in breathing. You know, we human beings, we take in oxygen, and then we bring out carbon dioxide, which a plant needs for its survival or in its photosynthesis process, as we said. So,
Mary, your time up.
Oh, sir.
Okay. Ibrahim, please, my time is up, but I've seen two hands up. I've seen a J and then Emmanuel. Emmanuel, your hand was up, and then a J too.
Yes, so
But
I
let's.
want to talk about the
sir.
aerosols. I want to talk about the aerosols. So I learned that for the aerosols, they are tiny particles and they are suspended in the air. And so, for example, we have the suspended soil or desert sand. Then we also have the smoke. And we said that they play functions. They have some certain functions. So we said that they moderate the temperature or they lower the temperature of the earth surface. At the same time, they also take help in formation of clouds, which leads to rainfall. Thank you.
Yeah,
Thank you very much. Please,
one,
my time is up, so.
let me add one thing. The aerosol is a fine solid particle. So add it. It's a fine solid. Said that. So not just a particle. A fine solid particle.
Mary, your time is up.
Thank you guys for your submission. Thank you very much for your contribution. And then we are handing over the mantle to our dear
Don't
Kofi
mention.
Sika.
Don't mention obeying. Don't mention obeying.
Our dear Kofi Sika to take over. Thank you very much. Thank you, sir.
All right, that's fine. I'm grateful that in fact online lecture though, but we are trying as much as possible to make all things better for ourselves. And like I always say, anytime you read you have an issue, you can just hit me on my line and we'll discuss it from there. I'm not a complex person. My line is always available. You can always call me. If you want to WhatsApp me, you WhatsApp me. But please just indicate, I am so and so, you're there. But then you say, don't say hi. If you say hi, I'll mind you. Because I have a lot of work to do, but I must also make sure I help everybody that is studying my course. All right, I wouldn't take questions, I wouldn't take comments, I wouldn't take responses. I'm being biased today, and I'm being also autocratic because from here I'm going to pick a 9 bus and go to Eastern region and be back on Wednesday. So, Mary, Schroeder, Ibrahim, Edu, Abba, is it Dixon? Please call me. The rest will call as and when it becomes necessary.
Kofi, last week I called you. Did you answer?
Okay, sir.
Oh. Yes, and then
Okay, thank you, sir.
All right, all the best to you all. God bless all of us.
Okay.
Thank you, sir.
Students call. Students call.
God bless you.
I'll call.
Students call.
Yes, sir, I'll call.
Call.
Obey call.
Obey call. Obey don't call. Don't call. Obey don't call.
Kwame, be careful.
Drink
it.
Order.
Wafa, Obiano, Fawalo.
Na sana za ye oben na Charlie ena chede yama submission yes one describing the man adjective one fe bi hihye man Charlie rade agogo
Hey, you people, what is wrong with you? Be careful, okay?
yango pon fi so mbahwe yan na yenzi mai pa
Oh, baby, I'm sure be here.
Amwa.
Christmas.
Sorry. Jai,
Mary,
me
oye, bias
not
for
being
Mary.
baba beji ni bi why. Grace ni bi.
Mate oben umbra.
Yede koma Mary.
Sa ode yede o sa ode Mary aware pepo. Oben wan kwa.
Yeah, sure say
Oben is gone.
Charlie, in fact,
remember, say online is so. Say also I will wait that one. Say all this that.
Oh, say on call Eastern region.
Online is so. Oh,
say Eastern region. In fact, course we can say no face to face and nice because most of the concepts are very technical. Very technical.
I was maybe who na
you are not a good person. You are a bad boy. You are a bad.
Go and sleep and stop worrying or being married. Go and sleep.
Anna Crispin, everyone there. Oh yeah, me code for me you me comments or online. We cannot do all of our courses online. Although face to face.
Yes, but I think we share right now looking at how scattered we are and some of the centers to obi that program no. This is a meme centers. I didn't register it, but Charlie. Me index number is 001. Your coaches and seminar me 3 bus. So because of how structured we need to, and just for our own convenience. But
I understand.
I think
I understand, but then
they
could have done something about it because extra almost online and most of the concepts are technical.
Yeah, that one they amper. That one there.
Most of the concepts we're talking about because Charlie, past question be on
You guys hello, you guys are trying to solve a problem which are not meant for you. They are not meant for you. Leave it for the code.
They are meant for no. Like say, you see, we are not the only one doing the course. A time will come and Bimbabe. Until at least if we set a precedence, because social questions be on the page and hey, I bought them crowd.
Inti ukrakra ne saying
The crowd crying say online, na again.
yeah na I know. They can't change anything again. It has been done. If there's a second block near Bekasa Hona why. And looking at some of us are
I
distance
was
here to there. Checking the fare is easy.
I was suggesting, sir. I was suggesting, sir. Mr. In the group, within the week, if maybe we can get a day.
What do you tell you? You oh, it seems an network now.
Please, are we there?
Oh yeah, it's a boss.
Find a day within the week. Nanka Yara, like we can.
We can have our own discussions.
Just have a reflection. Because, in fact, some of the questions is
I think Steven's network is worrying him.
Abba, try and call me. Try and call me in the evening.
All right, Prof. I hear. I will.
Okay. All right. Charlie, you wish you are
All right.
Yo, bye.
Question, mommy. Why? That's
I'm there. In fact, outdoors, me and my file door, but I'm the Telegram page. I don't know say if you are on that
platform. Platform, no.
Okay, no, yeah, I WhatsApp my jam. So. Okay, yeah, all right.
Okay, bye.
Bye.